Hi guys, I'm Shriya, and today I'll be giving an overview of some things you should know and some special pointers going into experiment 18, the chemistry of oxygen, basic and acidic oxides, and the periodic table. So basically an overview of what you're going to be doing, you're going to be creating your own oxygen, then exposing an elemental sample to that oxygen, and then seeing if an acid or base is produced when you add water to the products of that reaction. So making oxygen is obviously the crux of the lab, but understanding pH is sort of the biggest takeaway. So here we have something called POH, which is a term we don't hear very often, but it's just the opposite of pH basically. We know that the more H+ ions that are created in a solution when a substance is dissolved in water, the more acidic it is, and the more hydroxide ions there are, the more basic. And we measure how acidic or basic based on the concentration of the H+ ion generally, which is our pH. But we can just as accurately use the concentration of OH- ions with POH, but that's just not usually the way that you would describe a solution. So this chart basically shows the calculations you need to get each of the values here, the 4 values, based on what you have or are given. So if you have either the H+ or the OH- concentrations, you're basically just going to put 1 times 10 to the -14th over it and divide it to get the concentration that you don't have. This means that the H+ concentration and OH- concentrations are always going to multiply to get 10 to the -14th, which is the equilibrium constant, or like the constant of dissociation of water, but you don't need to worry about too much what the value actually means. So then from the concentrations, how you're gonna get the corresponding pH or POH depending on what you have, or if you have both, you can calculate either using the formula here, which is it seems a little complicated, but it's a negative logarithm of the concentration, which you just put it in your calculator, it'll give you the answer. Then once you've found either the pH or POH, you can find the opposite by basically understanding that the pH and POH are always going to add up to 14, which you know is the highest value on the pH scale. And you can follow these steps in any order to get what you're asked of based on what you have, and this should help with the pre-lab and the post-lab. So next we're going to talk about actually making the oxygen, which once you get the hang of it can be kind of fun actually. So you're going to be given this, you're going to be given this metal container kind of thing, which is called a pneumatic trough, and in it you're going to fill it with water, and then there's going to be this attachment here that has, in the middle it has like a hole. So basically you're going to fill a bottle with water, and when it's full you're going to cover the mouth with something flat like a piece of cardboard, and then you're going to turn it upside down and place it over the hole, and then you're going to pull out the piece of cardboard or whatever it is quickly so that no air goes inside the bottle, and so the mouth of the bottle is basically sealed over the hole that's in that attachment, allowing for basically a vacuum to form as the water in the bottle is going to meet the water in the trough with nothing in between. So then you're going to be given this tube kind of apparatus attached to the cork of another bottle here, and you're going to fill this bottle with a given amount of hydrogen peroxide, and then when you're ready for the reaction to start, you're going to add yeast, which you probably know will create oxygen. So after you put the yeast in, you're going to quickly close the bottle and shake, and yeah, the yeast will catalyze the formation of the O2 gas, which is then going to go through this tube and into the trough. Now as soon as the water in the trough starts bubbling from the O2 being released, you know that it's being produced. So you're going to put it up through the bottom here, the bottom of the hole in the attachment that you have the vacuum over, and allow the O2 to basically replace the water. And once all the water in the bottle is gone, you know it's been replaced by oxygen, and if you see it bubbling in the trough again, you know that it's definitely full, and you should immediately flip the bottle over this oxygen bottle and cover it so you don't lose any oxygen gas to the air. Then you'll have made your bottle of oxygen. So based on the specific instructions, you're going to either heat or ignite a sample and place it into the oxygen bottles that you created. And once you're done, you're going to fill the bottle with water to create an either acidic or basic solution, which you're going to test with pH indicator or a pH strip. However, some of the elements have specific instructions that don't require you to make your own oxygen to react with. So here's a list of the elements that don't require you to make your own oxygen. They create an oxide in a different way that you'll see that it'll explain to you. So I just made a list here so you don't waste time making more bottles than you need. And as long as you follow specific instructions for all of the procedures, for all of the elements, you should be in good shape. That's it for this instructional tutorial. It's not like a video or anything, but it should help you just get a context for the lab. It should make more sense. So I'm sure Mr. Seguin will go over more in detail how to actually do some of the steps, so have fun.